Hey everyone, thank you for joining. Good to see you today.
Hey, what's up, Anthony?
Hey Siraj, how you doing?
I'm doing great. Glad to be here.
Excellent. Glad to have you. And, thank you very much, everyone, for joining this introduction to Polygon. For those of you, well, for anywhere in the world, but particularly for those of you more on the East Coast America, Persuasion. This is a one of a two-part series that we're taking around the globe. Today is the introduction element, and next week on Thursday, an adjusted time, is the technical workshop aspect. We're delighted to have Siraj from Polygon, who's going to be taking us through everything. If you have any questions, please do use the chat function in Zoom. We'll drop a few links as we go along. Please join the Discord to keep up to date with everything. And many, many other great events are coming with Encode and Polygon together. Without further ado, I hand over to you, sir, and tell us about everything.
Awesome. All right. Thanks a lot, Anthony. So my name is Siraj Raval. I am an educator. I've been working on a YouTube channel for the past 5 years before I joined Polygon. I teach people about blockchain technology and about artificial intelligence. I'm very passionate about these topics. And I wrote a book called Decentralized Applications for O'Reilly, I guess, popular publisher for programming books. And I wrote that in 2014. And a little bit more about me. In 2014, I stayed in a hacker house in San Francisco. And one of the, yeah, I can share the book as well. Just give me a second. One of the first people that I met there who came to give a talk then to our hacker house was Vitalik Buterin, who is the creator of Ethereum. And I also met some other amazing people like Andreas Antonopoulos, who went on to write the book Mastering Bitcoin. I met Brian Armstrong, who had this Ruby on Rails app. Thank you, Anthony. Who had this Ruby on Rails app he called Coinbase that he was shilling to everybody and telling everybody that, hey, this is going to be something cool. And the community really didn't like it at the time. They were like, this is a bank. This is not what Bitcoin is about. But now Coinbase is a massive company. It's done so much good for the world. I met Juan Bennett. He was one of my roommates who later created something called Filecoin. So I had the privilege of being around these people 7 or 8 years ago. And ever since then, I've been trying to help teach people around the world about why Ethereum specifically is such a useful technology to build what are called decentralized applications. And the reason that, first of all, I think decentralized applications are so necessary for the world is because when the web started, it was decentralized. Everybody had their own blog that they hosted on their computer, on their PC at home. Everything was great. You had your own personal website. And then slowly over the years, we started to see this centralized element as the corporate structure that exists in the nation states started to be adopted on the web. And this caused everybody's data to be centralized. And eventually, all of the algorithmic manipulation that we're so used to today in terms of the news feed, in terms of not getting paid for your data, all of that is now commonplace. And so the reason that Ethereum is so beneficial is because we are trying to re-decentralize the web. Remember, the web started off as decentralized, and we're trying to swing the pendulum back to give the power back to the people. And I had a course on decentralized applications. I wrote that book several years ago, and I was so sure that developers would use Ethereum to build decentralized applications. But I was wrong in that my timing was so off. Every developer that tried to build a scalable decentralized application, when it came to the top apps like Uber or Airbnb or Twitter, they all failed. Mastodon failed. Lazooz failed for decentralized Uber. All of these dApps failed. And the main reason that they failed is because Ethereum was not scalable enough. And there was like this crypto winter that happened in 2017 after the ICO craze, where we were all wondering, like, is this even a valid dream? Can Ethereum scale? Should we even be doing this? And then along came Polygon, and that's how my hope got revitalized. Because what Polygon does is it helps scale Ethereum in many ways, on many different metrics. And that's what I want to talk about today. So let me go ahead and share my screen here and give you guys a little bit of an overview of what I want to share regarding Polygon specifically. So I'm going to share my screen. Okay, share. All right. So this is my book, Decentralized Apps, blah, blah, blah. You don't have to buy it. Go pirate it somewhere. Just search free PDF, decentralized applications. So let's get to this little slide deck we have here. So this talk is going to consist of 3 different parts: introduction to Web3 that I kind of touched on a little bit, an overview of Polygon, specifically the technology stack, Polygon Studios and NFTs, and then we're going to get into a workshop where we're going to, in the browser, build a DAO, right? A decentralized autonomous organization. If 2021 was the year of NFTs, 2022 is going to be the year of the DAO. And I want you to be a part of this. I want all of us, by the end of this talk, to feel inspired enough to create a DAO for something, because there's so much unlocked potential. You know, we can save the rainforest by creating a DAO for that. We can, you know, kids made a DAO for the Constitution. You know, we can make DAOs for things that nobody has thought of before. This is that wild pioneer time when it's okay to have crazy quote unquote ideas and make massive positive impacts in the world. So starting off with, what is Ethereum? Like I said, Ethereum is the reason that I got into this space in general. You know, we all know how Bitcoin works, more or less. If we don't know, just go to this website right here, andersbrownworth.com/blockchain. You can understand blockchain in under a minute if you look at this. You have a block, it's got 4 different parameters. You chain them together by creating pointers to each block, and that creates a chain of blocks. Very visual. If you change some data, you click on mine, it's going to try to figure out what that data is by computing what's called the proof of work algorithm. And then over time, the chain will be valid. If I were to change any of these numbers, you can see by red, the entire blockchain fails. So it's essentially a glorified linked list. If we've taken data structures and algorithms, it's a glorified linked list that lives on many computers. And because of the proof of work algorithm, nobody can modify it. Governments across the world, China, the US, every single major government has tried to destroy Bitcoin, and they couldn't do so. And the reason they couldn't do so is because it requires more computing power than the 500 fastest supercomputers in the world combined to do so. And nobody has that much computing power. But wait, you might be saying, what about quantum computers? Well, guess what? The Bitcoin core developers have already integrated quantum resistant technology into Bitcoin years ago. So even if we have quantum computers that have, 30 plus qubits worth of processes, it's still not going to be enough. But the reason that Vitalik created Ethereum is because he tried creating a proposal to the Bitcoin core developers. He said, well, can we add Turing complete smart contracts to the Bitcoin core? And they said no. And the reason that this was a valid reason is because that's a security concern. That's the same concern that Satoshi had. If you have a Turing complete capable blockchain, then what happens is an attacker could just create an infinite loop. And an infinite loop without any sort of blockage there could just destroy the entire blockchain, overload the block data, and then someone can double spend and destroy the entire network. And so it was a security concern. But what Ethereum did is they said, let's create a different blockchain that is Turing complete. And the way that we'll get around that's expensive to make every single computable block. We'll make it expensive for every piece of code to be computable. Ethereum is a virtual machine. It's got a stack, it's got a register. It's very similar to a CPU. It's got logic gates inside of it, embedded in it. And think of it like a decentralized Heroku. I don't know if you guys have used Heroku before, but Heroku is the go-to Web 2 platform to compile your web apps, even mobile apps, in a centralized server. And it does all of that compilation and running for you. That's what Ethereum is, except the difference is that Heroku, the team, can shut down their server and they can shut down your website. Nobody has that sort of admin access to Ethereum. So anything you put on Ethereum is unstoppable. This is good. This is good because no government can stop it. It's also bad because, what if it's some sort of malicious program? Nobody can stop it. And, if you have some sort of AI program that you upload to the Ethereum blockchain and its job is to figure out all sorts of destructive pathways, nobody could stop that either. So like all of these technologies, whether it's Ethereum or whether it's Neuralink that could be used to download information into your mind, but also give the government unlimited access to your head via thought crimes, AKA 1984, all of these technologies are both good and bad. It depends on how we use them. And Ethereum specifically is amazing because there have been so many dApps that have been built on this Turing complete blockchain. this shared database, this world computer that lives across the web. But the problem with Ethereum, like I said, is that this gas fee that makes it expensive to run multiple computations, that makes it expensive to run, say, an infinite loop, that prevents that, is the same reason why it's so expensive for anybody to do anything at this point, right? We are facing the blockchain trilemma. We want both decentralized, scalable, and secure. What Ethereum has done is it's created a blockchain that's decentralized, nobody controls it. It's secure and that nobody can modify it, but it's not scalable. And that's where Polygon comes in. It makes it scalable. And we can talk about NFTs, we can talk about all this stuff, but before we go to that, I want to talk about what Polygon is and how it solves the specific problem for Ethereum. Polygon was founded in 2017. Like I said before, remember, 2017 is when the crypto winter started. 2017 is when developers started to get disillusioned with Ethereum because of scalability issues. And that's when the founders, Sandeep Nalwal, Jayanta Konani, they came in and they said, what can we do to make this better? And the mission of Polygon is to make Ethereum infrastructure ready for mass adoption. How does it do this? Okay, how does it do this? And to explain to you how it does this, I want to point you to the Polygon documentation and give you a little brief overview of what this looks like. So if we go to Polygon Technology, this is our website, and if we go to the Technology tab, we can see that a couple of different frameworks. But what we want to do is we want to get started, and we want to look at building a dApp on Polygon. We're going to get started with that. And I want to look at the architecture of Polygon, an overview of the architecture. Okay, so right here, we have this nice little picture that shows how Polygon architecture works. So the green boxes are the Ethereum blockchain. Okay, so these are, like I showed you before, these are collections of blocks like this. These are glorified linked lists. That's what that is. And it lives alone, right? It lives on all of the miners' computers. And developers are building dApps on top of this. So, for example, if I have a decentralized social network, each block might contain a pointer to a data structure, which could be like a tweet. And a tweet has a certain set of parameters, like some 256 character text encoding, perhaps the owner, perhaps how many retweets, how many likes, how many shares, things like that, right? And each block contains that data. Do we store that data on the Ethereum blockchain? The answer is no. We do not store that data on the Ethereum blockchain because it would cause bloat. What we store is a pointer to that data. The data itself is not stored on the Ethereum blockchain. The data itself is stored in what's called the interplanetary file system. This is a decentralized storage mechanism. It is a network of miners. And if you want to be really technical, it's called a distributed hash table. It's very similar to a blockchain, but it's not quite a blockchain. It is a shared database that all miners it's kind of like a AWS. It's decentralized AWS. It's not running code, it's just storing data. But you might be thinking, well, how are miners incentivized to store this data? And the answer is something called Filecoin. Okay, now there are several different protocols. There's StoreJ. I'm very platform agnostic. I don't think one is better than the other. I just think that IPFS has had the most traction so far, and that's why I'm talking about it. Filecoin incentivizes these miners to store the data. And all the data, while being stored here, if we create a hash to represent all of that data, it's actually a Merkle DAG, where the highest level content address for your entire app is a 25-character key. All of the child nodes, right? All the child nodes are tweets for a user, and then one child node would be a tweet for an individual user, and then their children nodes would be each specific tweet, and it would form like a social graph. But it's one root chain, and that root chain can be posted to the Ethereum blockchain as a pointer. So there's two different things that we're storing in a decentralized fashion. We're storing our compute, our code. What is it that we want to run on the Ethereum blockchain? And then we're storing the actual data itself on the interplanetary file system. And that's all a long way of explaining what these green blocks are. So this machine that we built, this decentralized Heroku, this decentralized AWS that we built, it's running our dApp, it's working well. We have a couple hundred users, But then we hit a problem. Once we get to say, 1,000, 2,000, 10,000 users, the gas fees for making any sort of transaction are going to go up by a lot. And someone's got to pay for that gas fee. If it's us as a company or a DAO, that can get expensive. Now, if it's for the users, they especially don't want to pay that, right? So the way around this, the way that Polygon solved this, is they said, let's create our own chain. Okay, so we're going to create our own blockchain. And this is what's called a side chain. And it's a side chain because everything that we do in the Polygon blockchain is then submitted to the Ethereum blockchain as a source of truth. So when developers build on top of the Polygon sidechain, whatever it is, what the Polygon validators, are called validators, do is every X interval, they will take all of that transaction data. So whatever it's your compute, whether it's your storage data, whatever it is, and they'll post it to the Ethereum blockchain. And once it's on the Ethereum blockchain will validate, hey, are these valid blocks? Has anybody, tampered? Are they fraudulent? Is there anything wrong with them? And once they've validated them, then they live on the Ethereum blockchain forever. So in this way, because Polygon is a side chain, it doesn't suffer from the scalability of the Ethereum blockchain. Any dApp that's built with Polygon will have Ethereum security, because it's going to also, when you build for Polygon, you are building for Ethereum. It's going to have the security of Ethereum, the scalability of Polygon, and the decentralization of both. So there's this cross compatibility between both Polygon and Ethereum that you're not going to get anywhere else, because right now Polygon is the number 13. It still might be the number 13. We can check today. It's the number 13 biggest cryptocurrency by market capitalization. Let's see where it's at today. It is at, SHIB beat it. See, it's been going back and forth. It was 13, but SHIB beat it. It's 14 now. The reason it's so big is because we have all of these dApps that are built with Polygon. And if you're curious, because I know I would be, who's building interesting dApps with Polygon, I want you to go to this website. It's called awesomepolygon.com. And this website, awesomepolygon.com, is a way of showing what dApps are been made with Polygon. Cool. So these are some of the dApps that we built with Polygon. We have the most popular one is Aave, which is a decentralized finance protocol, DeFi for short. And there is over $28 billion locked in this decentralized. I think this might be the app that is built with Polygon so far. It is super scalable, super useful. I'm a big fan of Aave. Yeah, $25 billion locked on this. Nobody controls it. There's no bank. It's literally a protocol, and it's got this web interface that we can use to interact with it. But what you can do is you can stake Polygon, you can deposit, you can get loans from it. And why this is so important for the world is that if you live in a developed country like I do, the United States, you have a relatively stable banking structure, but most of the world does not have that, right? We have so many developing countries that don't have access to financial instruments. And we want to give those small businesses, farmers in developing countries, we want to give them the same access that we do. We want to have them be able to ask for loans. We want to invest in them. We want to give them insurance, things like that we take for granted. Most of the world doesn't have. And that's what decentralized finance, I think the long-term dream really is. And Polygon enables that. We can actually build that. And Aave is a great example of us doing that. But there's so many other options. Gravity.finance. Definitely check out this website, awesomepolygon.com, if you want to see different examples of that today. But let's get back to this architecture really quickly. So we have this sidechain, Polygon, and we can build on top of that blockchain. It's a unique blockchain. And when it comes to communicating with the Ethereum blockchain, we don't have to do anything. The validators will do that for us. If we as developers build with the Polygon SDK, if we build on top of it, the validators will post it to Ethereum. So compatibility is built in with MetaMask, with telling an Ethereum community, hey, use our dApp. We send them the link. They'll automatically be able to use it, even though it's a different blockchain. And and a couple more points about the Polygon blockchain. It is proof of stake. It's not proof of work. What the validators do is they are given some amount of money. They vote every X interval on whether or not a certain set of blocks is valid or not. And if you want, you can even delegate to those. You can delegate to those validators using the Polygon web wallet. So if we go to wallet.polygon.technology, we have our web wallet. It connects to our MetaMask. And right now I get, nothing here, but I can switch to my Polygon account here via MetaMask. Let me show you how that works. And then it's going to show, okay, so great. I've got, 14 cents, big money, right? 14 cents there, switch the account to Matic, and then pick an account with some funds in it. And 14 cents here. Okay, so once I've got that, I can, let's see, let's go back here. Right, so we can, let me see. We can stake. So what we can do as members of the network is we can delegate our funds to the validators. So there are two key users in the Polygon blockchain. We've got delegators, which could be any of us. Anybody with Polygon is a delegator if you want to, because you delegate, you give your tokens to what's called a validator. And validators are the ones that are confirming transactions. They get paid for it, and you get paid for it by trusting them with your coin. So if we want to be a delegator, we can click on Become Delegator. We can see like who here is legit. All right, let's see. All of these are validators. And one of the great easy ways of earning a return on your tokens is to delegate. I think it's 12% on your tokens by delegating to one of these validators. So let's see, BlockOps has 10 million Matic tokens. I can click on delegate here. And whatever it is, I can delegate to them. They're going to then use those funds to validate transactions, and that's how the network works. Now you might be thinking, well, proof of stake isn't as secure as proof of work, and that's true. I agree with that. It's not as secure as, say, Bitcoin. Bitcoin is really the king in terms of security, but Ethereum is moving to proof of stake, hopefully this year. That's on the roadmap, and Polygon's just ahead of the curve. One more thing I want to talk about when it comes to the architecture of Polygon before we get into NFTs and different applications, and that is that the way that Ethereum validates that the activity happening on a different blockchain, like Polygon, is valid, that it's not fraudulent. The way it does that right now is by using a technology called Plasma. And Plasma is math proofs that validate a tree of data, specifically a Merkle DAG. And Plasma works. This is how Polygon works right now. We're a Plasma sidechain, but Polygon has spent, I think, about $1 billion today on acquiring the industry's leading zero-knowledge rollup solutions: Miden, Nightfall, Zero, Mirror Protocol. Every single major zero-knowledge startup, Hermes, has been acquired by Polygon. And if you look at, except for ZK, I think it's ZK Stark, we haven't acquired that one, but Vitalik himself said that zero-knowledge rollups are the key to scaling Ethereum via layer 2. And what zero-knowledge rollups do is they allow the Ethereum blockchain to accept a proof that is computed by a sidechain. The sidechain will take thousands, hundreds, if not thousands of transactions, roll them up into a single hash, and generate a validity proof. That's a math proof that says that all of these transactions are valid. And because the transactions are rolled up into a compressed data format, it is scalable, cheaper, faster, all the ERs, and that's really the future. So right now we have Plasma, but this year we're going to switch to zero-knowledge rollups, and that's just going to make everything better for both Ethereum and for Polygon. And we've already done the acquisitions to show, we put our money where our mouth is, basically. Okay, so yeah, let me see if there are any questions here. I can pause for questions before moving into applications. What's your view about competing L1s? So competing L1s, so the big ones that come to mind are Solana. I think Solana has the most traction as a competing L1. Yeah, so what do I think about Solana? I think Solana has a great marketing team. I will definitely give them that. Solana went down recently. Solana is Very fast. I will give it that. But remember the blockchain trilemma. It's like a triangle. Decentralized, scalable, secure. Pick 2 of 3. What Solana did is it picked scalable and it's picked secure, but it sacrificed on decentralization. Now, and it did that by creating a very, very centralized set of validators. Polygon's validators are distributed globally, and Solana's validators are very centralized. They're all communicating in a Slack channel. And furthermore, I think Solana is pre-mined a little bit too centralized as well by Andreessen Horowitz, one of the major venture capital firms in Silicon Valley. I don't think that Solana is. I think it's kind of like a temporary solution, because we already have a very, very fast scalable solution called Web 2, right? It's super centralized. And yeah, basically that's my thoughts on Solana. I think it's a little too centralized for me, but they do have a great marketing team. What is the biggest dApp on Polygon? I'm pretty sure it's Aave. What are the new features coming to Polygon? Well, a lot we can't talk about, but one thing I can say is that expect a lot more in zero knowledge rollups for us. What language do you need to know to use Polygon? This is the great part about Polygon. You only need to know the language of Ethereum, the main smart contract language, and that is Solidity. Like I said, if you're an Ethereum developer, you're automatically a Polygon developer. And we have SDKs in multiple different languages: JavaScript, the language of the web, Go, Python, and I think we also have a Java implementation. It might not be official, but it is there. What scale can Polygon handle? Well, right now we have $16 billion worth of and there's no sign of stopping. If you go to one of our co-founders, Mihailo Bielik's Twitter page, he's always posting stats, and it's just exponential in growth. What effect will ETH 2.0 have on Polygon? So that's a huge upgrade. And I will echo what Vitalik said. So ETH 2.0 is not a one-time event. It's not like you snap your fingers and all of a sudden we have ETH 2.0. It's a transition period. And it consists of several scalability solutions, both in L1 and in L2. For L1, it includes solutions like sharding, which is in progress, taking blocks and splitting them up into many different blocks, and then distributing them across the network in different ways. So that's sharding. There is increasing the block size. That's one, which is highly debated. There is moving to proof of stake from proof of work. That's also on L1. And then for L2, it's moving to zero knowledge rollups. That's what we're doing. That's the main one. There are state channels. If you've heard of the Lightning Network for Bitcoin, that is using what's called state channels. We don't do that right now, but we might think about that. And then there's Plasma, which is what we already do. So all of these things are essentially ETH 2.0. And like I said, they're not going to all happen at once. It's not centralized in that everyone, one person gets to decide when all these will be implemented. It's going to take a lot of consensus from the community. But if you were to ask my bet on when ETH 2.0 will be ready or like good enough, let's say, I think it will be this year, finally. Why are NFTs so cheap on Matic? So it's kind of like what I said before, where all of that activity, if you want to mint an NFT, you mint it on the Polygon blockchain, which doesn't have the size of Ethereum's blockchain, and you can mint it very cheaply precisely because of that. It's much smaller a blockchain. And once you've minted it, Polygon's validators will create a transaction hash that is posted to the Ethereum blockchain that represents that NFT. So by minting on Polygon, you are also essentially minting it on Ethereum. It's kind of a hack. You get that immutability of the Ethereum blockchain without having to pay the gas fee, right? That economic infrastructure is shifted from it coming directly from you to coming from the value that the validator is providing the network in terms of proof of stake. If ETH 2.0 goes live with no hiccups, what role would Polygon have? That's a great question. So Polygon is ETH 2.0. There is no ETH 2.0 without Polygon. Like I said, Vitalik said that zero knowledge rollups are essential to ETH 2.0. He said it on Reddit. He said it at our ZK Rollup Summit that we had in December, which is live on YouTube. And he said it on Lex Friedman's podcast. So he said this several times. He also donated, I think, $1 billion to the Polygon co-founders. So he's very much into Polygon. And that's honestly one of the reasons I joined Polygon, is because Vitalik believes in it so much. I'm going to answer one more question before getting back to this. Are there any core differences between Polygon and Polkadot? Are they interoperable with one another? So Polkadot is an L1 solution. It aims to compete with Ethereum directly on a few key design decisions. It is orthogonal to what Polygon's trying to do. We're not trying to replace Ethereum. We're trying to scaffold. We're trying to lift up Ethereum. Are they interoperable with one another? Yes, they are. Yes, we are focused on Ethereum, but let's just say, like, worst case, let's say something happens to Ethereum. We still have that infrastructure to help lift another L1 solution. So, if so be it, some random black swan event occurs and Ethereum just somehow collapses, we could, whatever's the next L1 will help scale that. Because in the end, we love Ethereum precisely because it has that first mover advantage in the dApp community. But in the end, we all have a shared mission of increasing financial access to the world, creating a more open, transparent web, moving us towards Web3. And absolutely, we're all going to make it. All right. Flag me. Oh my God. I shouldn't have missed out that. Okay. So let's get back to this. All right. So what is the next thing I want to do? I want to quickly finish this, this slide, and then we're going to move into a little bit of coding. Okay. So when it comes to NFTs and when it comes to gaming, Polygon is like the leader in the blockchain space. OpenSea, Decentraland. I'm actually going into Decentraland later today. Avagachi. All of these games are built with Polygon. When it comes to NFTs, like, if you want to get into NFTs, you don't even have to be coding. You can just go to OpenSea like this. You can just, you can click on create. We'll just mint an NFT right now. How about that? You can click on create. It's going to open up MetaMask. It's going to ask you to connect to a blockchain, sign it. Okay. So I'm right there, create a new item. I'm going to import some image. I'm going to turn it into an NFT. So how about my picture right there? I'm going to call it NFT demo. I'm going to say the description is NFT demo. And there's no collection, blah, blah, blah. Here's a blockchain, Ethereum. But hey, look right here, a fast, gas-free blockchain that works with Ethereum, Polygon. Now, if we minted it on Ethereum, it might cost some money. Quantities above 1 coming soon. So yeah, for one, we can mint 1 on Ethereum for free. But see, it won't even let me select 2, right? See, I can't change it. I'm trying to. But with Polygon, we can, have 383 copies of this. See, we can have a lot, and it's all gas free, and it still is viewable on the Ethereum blockchain. So I'll click on create, waiting for my signature, and you can, just proof of minting right here. Waiting, please wait. And there, in 15 seconds, I just minted an NFT. There it is. Okay. That's how easy it is to mint an NFT with Polygon. And yeah, so that was the first demo. And go buy this NFT for $4 million. I'll be happy. I'm just kidding. You don't have to do that. But I can set a price too. How many Ether do I want to sell this for? How about 22 Ether? And they'll charge a service fee, the platform, complete the listing. And nobody has that kind of money. And I'm going to unlock it. So $74,000 for this image, which nobody cares to buy. And I'm going to sign it, unlocked. And we're done. Sign. Oh, I got to do a signing thing, and then it'll be over. Signing. Now it's listed. It's got a price. It's got everything. It's on OpenSea. It's gonna benefit from its discovery engine, and someone's gonna buy it. Hopefully, never. Okay. So let's keep going here. So what else do I want to do here? So the next thing I want to show you is we've talked a little bit about the architecture. We've talked about where we're headed. We've talked about a couple different things. Now I want to show you a quick little demo. Like I said before, I want to show you how to make a DAO. really quickly. So when it comes to where do I start building, right? So the first answer to that question is we have the documentation right here. I'm also going to show you this little sneak peek of what we have. It's called Polygon Academy. We haven't actually released it yet, but I'm going to cheat a little bit and just show you guys right now. You can actually access this on the web, but we haven't like publicly released it yet. It's called academy.polygon.technology. I'm not done building it. That's why we haven't released it publicly, but we basically curated all of the different resources that are on the web about Polygon. And we've created this like learning path for developers. So every single different dApp idea that you could possibly imagine, we've got a tutorial for it right here. Mint and NFT marketplaces, DeFi analytics, create an art gallery, quadratic voting, real estate, just everything is right here. So definitely check out academy.polygon.technology. Do you want to learn more? Don't tell anybody I told you about that. And then what else? The starter kit is the best way to set up your own dApp, right? This is like a skeleton dApp. And once you install it locally, it's running on localhost. It's going to say hello world. Then you can add your functionality. Then you could turn it into decentralized Airbnb, decentralized Uber, decentralized Twitter, whatever your world-changing dApp is going to be, you can change it to that, right? But you need a starting point. And that's what this starter kit does. And it's also on the Academy, by the way. You just have to, this has all the dependencies you already need built in. All you need to be worrying about is the creative world-changing aspect, not the installation and demo stuff. Okay, so that's that. Now I want to get to this little quick little demo for you. And this is a dApp by this developer named Party Like It's 1983. And I found it by scouring GitHub a little bit, and it's a little lesser known dApp. And what it is it is a Solidity smart contract. And what it does is it creates a DAO, a decentralized autonomous organization. And what this DAO does is it votes on whether or not someone can buy a cupcake from a digital vending machine. That's all it does. It basically creates two smart contracts. And this is an architecture, okay? The first smart contract is the vending machine itself. It's a digital vending machine. And inside of this digital vending machine are digital cupcakes. And these digital cupcakes are represented by numbers, specifically the number 1 if there is a cupcake, and the number 0 if there's not a cupcake. That's the first smart contract. That's all it does. It holds this data, just like a real vending machine holds real cupcakes. The second smart contract is for the DAO. And what the DAO smart contract does is it does two things. The first thing it does is it holds some funds in a treasury. The second thing it does is it lets a set of users that it has in its list, the DAO participants, vote on whether or not the DAO can buy a cupcake from the vending machine. So what will happen is that a user will give 1 Ether to the digital vending machine, or the DAO can give 1 Ether to the vending machine, and in return, it'll return a digital cupcake. So if I'm an independent user, I can buy a cupcake. I don't need to ask anybody's permission. I can do it myself. That's this left-hand side right here. On the right-hand side, if the DAO decides to buy a cupcake, before a digital cupcake is returned to the DAO smart contract and all the participants can share fractionalized ownership, they will all have to vote yes or no. And the majority vote will unlock that transaction. So at least 66% of users have to vote on yes or no on whether or not they want to buy that cupcake, and then it will happen. So in order to build this, I'm going to show you this thing called Remix. And Remix is an online integrated developer environment for Ethereum. And now, like I said before, anything that you build for Ethereum, you can build with Polygon. And if you're curious how that works, go to the Polygon starter kit, and all you have to do is switch the blockchain right here in truffle config.js from Ethereum to Polygon. And so that just means just adding this. It's actually all already in there for you. You don't have to change anything. But these two blockchains are compatible. But this would work on the Polygon chain as well, just FYI. So we have Remix. It's an online integrated developer environment. And what we're going to do is we're going to create a contract. And this contract is going to create this DAO for us. So the first step for us is going to be to find this digital vending machine smart contract. So we'll go to digital vending machine, and we're going to paste that in as the first smart contract. And then we're going to go back to Remix. We're going to create this. We're going to call it digital, not create a workspace. We want to create a file. And the file is going to be called digital vending machine.solidity.sol. Paste that in there. Okay. And now that that's in there, let's take a look at what it looks like. It's 30 lines of code. We have an owner of the vending machine, whoever that is. In this case, it's going to be us. And we have a balance of cupcakes. How many cupcakes do we have in this thing? When we construct this similar to a class file, we'll define who the owner is, whoever defines a smart contract by creating that initial transaction, and then how many balances. So we're going to start off with 100 cupcakes, okay? And then we have two functions that this does. It refills, which only we can do. We can add cupcakes, and it allows someone to purchase some cupcakes from it. That's all it does. So we'll go to the compiler because it's a statically typed language. We have to compile first, and we will compile that Solidity file. Okay, and once it's done compiling, it's going to take a second to compile. We can publish it on IPFS. And go to deploy that contract. And now it's deployed, and we can see it right here. Okay, and now what these buttons allow us to do, as you can see, these buttons correspond to each of these functions. There's a purchase, there's a refill, there's a cupcake balance button. Okay, so I'm going to move this up here, and we can purchase, some amount of cupcakes as well. This is just for testing, but this is not going to work right now. We can just click on owner to see who the owner is. There's our owner address. Okay, but before we do this, we need to create that other smart contract. So remember, there are two smart contracts. The first one is for the vending machine, and the second one is going to be for the DAO itself. So, we've heard a lot about DAOs, and here's a DAO in, I guess, 185 lines of code. If we took out the spaces, it would probably be 120, I would assume. So let's create the second smart contract in Solidity. So we'll go back to this, we'll create a new file, we'll call it dao.sol, paste it in here. Let's take a look at what it looks like. It's going to need the vending machine address. I'm going to have to give it that. It's got a time for voting to happen. It's got a balance that everybody has shared ownership over. Balances represents whether or not we allow withdrawals, and ended is whenever the voting time ends. Decision is going to be a Boolean, yes or no. In this case, it's a uint, so 1 or 0 corresponds with yes or no. Then we have voters. There's how many voters are we going to have? Each voter has a weighted vote, and they can either delegate their vote to someone else or they can vote themselves. And the voters can create proposals. Proposals have names, and then they have a count of the vote. The chairperson is the person who sets up the vote, and then we have event handlers for whether or not the vote has ended. In the constructor, we define all those parameters that we just talked about. And then we have these key functions right here, deposit ETH. Remember, how much money do we want to deposit into the DAO? This is what defines that. Delegation, who do we want to give our right to vote to? We might not want to. We might want to vote for ourselves. There are many different ways of structuring a DAO. A representative democracy like the United States, we delegate our vote to these representatives in Congress. But in a direct democracy, like say Athens, back in ancient Athens, every person got their vote. There were no representatives. It depends on how you want to structure your DAO. A DAO could even be a dictatorship, right? It's basically a way of rapidly designing different organizational structures immediately. Vote, here's this voting function, which defines whether or not I can vote. Do I have some money associated with my vote? The count vote function will count how many votes have occurred after the tallied vote time has ended. The withdraw function will let me withdraw any money that I've deposited into the treasury back. And the last function is end vote. When the vote ends, when the voting time ends, who gets their money back? Will we buy some digital cupcakes? What happens? So these are all essentially error checking functions. Okay, so that's the DAO. Let's now compile the DAO here. We'll go back to here, compile DAO.sol. We could do this all locally as well. I like to use Remix because it's in the browser. It's fast. We don't have to think about dependencies too much. And it's just a way of rapidly developing. So once it's compiled, then we go to the deploy and run function, and we'll click on deploy. Now it's going to ask for that vending machine address. Where do we want to deploy to? And I have that right here, that address. So I'm going to copy that address here, and I'm going to paste it here. That's where we want to deploy it to. And okay, vote time. What's the vote time going to be? Let's say 23 seconds. What are our proposals going to be? 1 for voting yes, and then 0 for voting no. These are the parameters for that. Okay, so now I have deployed that. So now you can see it here, simple DAO. And here are the buttons that correspond to all of the functions that I just defined right here, right? So what's the DAO balance? 0, because I haven't given it any money. I can vote, I can deposit some Ether, I can count how many votes there are total, all of this stuff right here. And, you know, we could recreate this using the starter dApp that I showed you right here by downloading this and then adding these Solidity files to the starter dApp, and it's going to be running on Polygon just as easily as it's running on the Ethereum testnet in this Remix browser. Okay, so all that is to say, there's a lot that we can do with Polygon. I definitely want you to check out the Academy. Okay, I want you to go to academy.polygon.technology, and I want you to start building dApps of your own. One more website I want to show you to help you out here, Figment. It's one of the best. Every single tutorial here is based on a different application-specific use case. Lending dApps, poly market clones, social media dApps, to-do dApps. Any idea you have, this is going to get you started with how to do that with Polygon. All right, so let me now see if there are any ending questions, because that finishes the I guess lecture part of my talk here. What is a DAO, would you say, in the simplest terms? In the simplest terms, I would say it is an internet organization that has money attached to it and voting. So an internet organization with shared money and voting. An unstoppable internet organization with shared money and voting. How about that? Because you could create a Discord channel and you could put money in there, but some person is going to control that money, right? But in a DAO, you can lay it out very transparently in a smart contract, as we just saw, where the funds are. If someone tries to withdraw those funds, who is withdrawing those funds? We can trace it. And so it just eliminates corruption. It eliminates insider anything. It makes it fully transparent. Last question is, this is a very technical one. Currently deploying SC from Hard Hat to Mumbai testnet, getting issues in Polygon scan, mixing transactions. Any advice on that? That's a very specific development question. And I would say, please ask it on the Polygon Discord channel. There's tons of developers ready to answer those questions. And also send a picture of your exact stack trace of the error. Okay, so that's it for my talk. Thank you, everyone. And I'm going to hand it back to Anthony now.
Oh, Siraj, that was awesome. Thank you very much. I think a fervent number of questions, and I really enjoyed it. And I did see someone messaging me privately going, "This might be the best speaker we've ever had at Encode." I think a testament to your particular presentational ability. So thank you very, very much. And thank you everyone for joining us for this event, well, for you afternoon, for me evening, and for some of you, maybe even mornings as well. I do remind you about the next event next week, which is on Thursday. So not on Wednesday, it's on Thursday. I'll just leave the event right here. This event was recorded and will go up on the YouTube and the Medium tomorrow morning European time. In the meantime, thank you very much, Siraj, much appreciated. Thank you all for coming, and we'll see you all very soon. Have a great afternoon, evening, morning, wherever you are.